Every night, a busy application writes fresh log files into the cloud. Requests, errors, audit trails, thousands of small objects, each one a blob. On day one, they feel urgent. Someone might need them in a second, so they sit in the fastest storage money can buy. Fast forward a few weeks, those same logs are still there. Almost nobody opens them, yet the bill treats them like emergencies. That is the quiet contradiction inside cloud storage. Data does not stay equally valuable forever, but without a system, it keeps paying as if it does. What if yesterday's data could move itself without someone babysitting every file? Azure Blob Storage does not offer one kind of shelf. It offers access tiers, different rooms for the same object, each with a price and a speed. Think of two rivals. Hot storage is the premium floor. A blob there costs the most, and you can reach it very fast. Archive storage is the deep basement, cheaper to keep, slower to retrieve. Between them sits cool storage, a middle ground when data cools off but is not ready for the vault. The tiers exist because usage changes over time. A log from this morning belongs on the hot floor. A log from last quarter rarely does. Here's the part that matters. Inventing cheaper rooms is easy. The hard problem is deciding automatically when a blob has stopped being today's emergency and become yesterday's archive. Why build tiers at all? Because a storage system that treats every byte as an emergency is a system that taxes growth. Imagine a city warehouse. Fresh orders sit by the loading dock, expensive square footage, forklifts ready. Last year's sealed cartons do not need that dock. They need a dry aisle further back. Azure's hot tier is the dock, highest cost, fastest hands. Archive is the far aisle, cheaper rent, slower retrieval. Cool sits between them when you still might need the carton this month, just not this minute. The source puts the contrast bluntly. A blob in the hot tier costs the most and can be accessed very fast. A blob in the archive tier is cheaper and slower. That sentence is the entire economic plot. Everything lifecycle management does is a way to move objects along that plot without a human pushing each box. Enter lifecycle management, Azure's rule engine for this exact fight. It does not guess. You write a policy once, and the platform evaluates blobs on a schedule, then moves or deletes the ones that match. In the Azure portal, open a general purpose storage account. In the service menu, you will find Lifecycle Management. From there, you can create a new rule. No scripts, no nightly human checklist. A policy becomes a workflow. But a powerful rule aimed at the wrong objects can be as wasteful as having no rule at all. So the first question the story forces on us is simple. What exactly should this rule be allowed to touch? Let's slow down on the portal moment because this is where the abstract policy becomes a clickable object. You are inside a general purpose Azure storage account, not a special lifecycle product, just the same account that already holds your containers. In the Accounts menu, under Data Management Ideas, Lifecycle Management appears as its own blade. Open it, and the empty state is almost provocative. There is no hidden default demoting your data. Until you add a rule, nothing moves. Create a new rule, and the wizard frames the truth in one line. A rule is made of conditions and actions that can apply to the entire account, or, optionally, only to particular blobs limited by filters. That optional word is doing heavy lifting. It is Azure admitting that power without boundaries is how outages and surprise deletions are born. A lifecycle rule starts with identity and reach. Give it a name, something you will recognize months later when the bill drops and you wonder which policy did the work. In the walkthrough, the rule is simply called My Rule. Next comes scope. You can apply the rule to every blob in the storage account, or you can limit it with filters you define later. For a careful design, choose the limited path. You are saying, this policy is not a blanket. It will only fire where we point it. That choice is the difference between a scalpel and a flood. The name is bookkeeping, the scope is power. Not every object in a storage account is the same kind of blob. In this setup, we only want block blobs, the workhorse type used for most files, logs, and media. Append blobs can stay out of this rule. Then comes subtype. Base blobs are the live objects you think of as the file. Snapshots are point-in-time copies frozen beside them. Versions are another trail of history when versioning is on. The example leaves the rule on base blobs alone, but the portal lets you include snapshots and versions if your retention story needs them. Picture a busy logs container. Today's active log file is the base blob. Last week's frozen copy might be a snapshot. Touching one without the other can leave ghosts that still cost money, or delete history you meant to keep. Scope alone still cannot tell the system when storage should change. For that, the rule needs time. Here is the heart of the policy, the if block. Azure asks, were the base blobs last modified more than a certain number of days ago? In the worked example, that number is 20. 20 is not magic. It is a business judgment dressed as a number. If nothing has written to this blob for 20 days, we will treat it as cooled off. The clock is last modified time, not a prediction of human curiosity. A file nobody opened can still be recent if something kept rewriting it. A file everyone forgot can still be hot on disk until that threshold passes. Lifecycle management can stack multiple if-then blocks, and when several rules exist, actions should follow tier order. Hot toward cool, then archive, then deletion. So you do not leapfrog the ladder in a broken sequence. The age condition answers when. It does not yet answer what to do. One subtlety on the base blob step matters more than the checkbox styling. Lifecycle management uses your rules to move blobs to cooler tiers or to delete them. If you create multiple rules, the associated actions must be implemented in tier order, from hot to cool storage, then archive, then deletion. That is not bureaucracy. It is physics of policy. If one rule tries to archive on day 10 while another still expects a cool stop on day 30, you get contradictions, objects skipping floors or delete racing a move. Think of a descending staircase. Each tread is a state. Hot at the top, cool, archive, delete at the bottom. You may skip a tread on purpose. The example jumps from hot toward cool and delete remains available. But you should not write two rules that fight about which tread comes first. The 20-day cool move is one clean tread down. Keep the staircase legible. The then block is the decision. Once a blob crosses the age line, Azure can move it to cool storage, move it to archive storage, or delete it outright. In the portal dropdown, move to cool storage is called out as the reliable option when cost is not the only priority. You keep the data, just on a cheaper floor. Archive goes deeper, lower cost again, but the blob cannot simply hop back to cool the way you might expect, and retrieval is slower. Delete is the most efficient option when backing the blob up is not a priority at all. Our example chooses cool. The logs are old enough to leave the premium floor, not old enough or unimportant enough to erase. That is the mediator at work. Hot wants everything nearby. Cool and archive offer savings. Lifecycle management picks the moment of transfer. Even a perfect age rule, though, can still touch the wrong neighborhood of data. Stay with the action menu a moment longer. 3 futures for the same aging blob. Move to cool storage. The walkthrough's pick. Keeps the bits. You still own the history. You simply stop paying hot prices. The portal even frames it as the most reliable option when raw cost is not the only priority. Move to archive storage goes further underground. Archive does not fully delete the blob, yet it cannot be moved back to cool storage the way a casual user might assume. And getting bytes out is slower. Delete the blob is final efficiency when backing that object up is not a priority. For application logs, cool is often the honest middle. Regulators or incident reviews may still ask for last month's trail. Archive might be right for cold legal holds. Delete might be right for noisy debug dumps. The tool does not choose your ethics. It only enforces the ethics you encode in the then block. So we narrow the blast radius with a filter. On the filter set step, Azure offers a prefix match. A prefix is a path style string. Enter the container name first, then any deeper path you care about. In the example, the prefix is slash logs, the logs container. That single string turns a storage account wide idea into a targeted policy. Blobs and other containers keep their current tier. Only objects living under logs will be evaluated against the 20-day rule. Think of it like a building directory. Without a floor number, your maintenance order hits every wing. With slash logs, the crew only visits the logs wing. Add the rule, and there it is. A named policy, scoped, timed, and fenced. Filters deserve a craftsman's pass. A prefix match finds folders and blobs that start with the string you type. Type a lone letter, and you might match far more than you meant. To pin a container, enter the container name first, then any deeper prefix inside it. For example, my container slash prefix. The worked example types slash logs. That targets the logs container as the neighborhood under management. Second line blanks stay empty when you do not need a deeper folder cut. This is how a single age role becomes safe enough for production. Finance blobs, media blobs, backup blobs, they can live in the same account and never see this 20-day cool transition. Only the logs wing ages out. Add the rule when the filter is right, and the policy list shows it alive. From that moment, the account has a standing answer to the opening contradiction. Walk the whole flow once, the way an operations team would feel it. Monday morning, an API writes request logs into the logs container as block blobs on the hot tier. Engineers tail them, dashboards read them, incidents depend on them. Day by day, the write's slow. By day 21, last modified is older than 20 days. Lifecycle management evaluates the rule named myRule. Scope says filtered block-based blobs only. The if block matches. The then block moves those objects to cool storage. Prefix slash logs keeps a metrics container untouched. Nobody filed a ticket. Nobody ran a script at 2 a.m. The system stopped treating yesterday's telemetry like today's emergency, but only where the story said it was safe. That is the detailed machinery behind a deceptively short portal wizard. Name, scope, blob type, subtype, age, action, filter. Before we celebrate automation, name the ways this story goes wrong. Still inside what the source teaches. Forget the filter and limit nothing. Every block-based blob older than 20 days drifts to cool, including objects your latency-sensitive API still expects on the hot floor. Include snapshots and versions without a retention plan, and you may demote or delete history you thought was protected, or leave billable ghosts if you only moved the base. Choose delete because it looks tidy, and an audit asks for the log you erased on day 21. Or write 2 rules that ignore tier order and watch actions quarrel. Lifecycle management is easy in the portal precisely because each step looks small. The discipline is treating name, scope, type, subtype, age, action, and filter as one sentence. Remove any clause and the meaning changes. So what changed? At the start, every aging log risked paying hot tier rent forever, or depending on a human to demote it by hand. Access tiers gave us different rooms. Lifecycle management turned usage into an automatic move between those rooms. Azure Blob Storage access tiers are genuinely useful for cutting storage costs. Lifecycle management is how you make that promise real without constant manual tier chores. Moving blobs to the appropriate tier based on how they are actually used. The opening contradiction is resolved in practice. Data stays available under policy, while older objects can occupy a cheaper floor on their own. One question the field still has to answer, organization by organization, remains open. Which data still deserves speed, and how much delay are you willing to accept for the savings?